quadratic formula. So we now have this formula that we can use to solve any quadratic, provided that the quadratic is in standard form set equal to 0. So we're going to take a look here at a couple examples, and the first two examples, what we're going to see is that the equation is already set equal to 0 for us. However, in our last example, we're going to address what we need to do if the equation is not set equal to 0. So just to kind of get started here, with the quadratic formula, we also remember the fact that we have this special portion inside the radical known as the discriminant. And so that discriminant then tells us, the types and how many of the solutions we have. 2 imaginary, 2 real, or just 1 real solution. So we can keep that in mind as we're working through the process. All right, so let's go ahead and take a look at our first example. And in our first example, nothing too crazy taking place here. It's a pretty average problem given the fact that, again, it's already set equal to 0. So what I'm going to do is I'm basically going to apply the quadratic formula, which says the opposite of b, which is 4, plus or minus square root of b squared minus 4 times a times c, all over 2 times a, which is 1. So again, you can have different ways that you want to go ahead and evaluate this once you have all the values substituted in. So I typically like to work with that discriminant area first, but I'll simplify a little bit of everything here in my first step. I have negative 4 plus or minus 4 squared is going to give us 16 minus 4 all over 2. And then from here, I can see that I'm going to have x equals negative 4 plus or minus 16 minus 4 is 12 over 2. Now this is the one area that it helps us kind of going back to a previous section when we were simplifying radicals. You see here that I have the square root of 12, and I have to realize that there's a perfect square hidden inside there. So this is actually negative 4 plus or minus 2 square root of 3 all over 2. Now that's important for us because now what I see is that I have a common factor that I can reduce out of all the terms and with the value that's in the denominator. All right, so whenever I simplify, I have to make sure that this value simplifies with both. I can't just do it with one. That's a common error that students often make. So therefore, my final answer in this case is going to be negative 2 plus or minus the square root of 3. Because again, this 2 reduces with the 4 and with that 2. So there's our final answer. If we take a look at the second example, you can see pretty similar, all right? It's definitely a similar type problem, but now, over here we had a leading coefficient of 1. Now we have a leading coefficient that's a negative 2. Nothing too drastic. The main thing here is the fact that it's still set equal to 0. So if I'm going to go through, again, I start off by substituting the values. Opposite of b is 1 plus or minus square root of 1 squared minus 4. My a value is negative 2. My c value is 4. And this is over 2 times negative 2, like so. So again, in the actual simplifying process, I get negative 1 plus or minus square root. This will be 1. Now, I see that I have 2 negatives here. So I have negative and a negative. So that's going to tell me that I'm going to actually be adding, or I'll have a positive here. And then this is going to be 4 times 2, which is 8. 8 times 4, which is 32. All of that over negative 4. This is going to result in x equals negative 1 plus or minus square root of 33 over negative 4. We can leave our answer like this. You could also simplify the negative. Either way would be acceptable, but you'll see that in this case, 33 doesn't have any perfect squares, so we don't have any further simplification process in this question. Before we kind of go into the third one, what I want to do is actually show you the third one and then have you go through that similar process of, all right, make a hypothesis of how you would go through and try to solve this using the quadratic formula. And then whenever you're solving it using the quadratic formula, I want you to also think, well, did I have to use the quadratic formula? Or could I have tried to solve this in a different manner? So at this time, I'm going to actually end this presentation, and then I'll have this third example worked out in a future presentation.